Hello, this is section 4.1, Solving Systems of Equations. Solving systems by graphing. A system of equations is a list of equations that you deal with all at once. Our focus here will be on systems of two linear equations. Definition 1. A solution to a system of two variable equation is an ordered pair AB such that it is a solution to both equations. Example 2. Determine whether each ordered pair is a solution to the system. So, as a reminder, the first coordinate is x, the second coordinate is y. So, we just need to plug this into both equations and see if it works. So we get 1/2 times -4 plus 2. Does that equal 0? That's -2 plus 2. Does that equal 0? And we get 0 equals 0. And it works in the first equation. But that does not mean that it's a solution to the system yet. You have to plug it into the second equation as well. So we get 0 equals 3 times -4 minus 3. Does 0 equal -12 minus 3? And does 0 equal -15? It does not. So this is not a solution. And now let's check the point 2, 3. So you get 1/2 times 2 plus 2. Does that equal 3? That's 1 plus 2, which means 3 equals 3. So again, this point works for the first equation. Then we get 3 equals 3 times 2 minus 3, which means does 3 equal 6 minus 3, and we get 3 equals 3, and it works. So since it worked in both, yes, this is a solution. Geometrically, we can think of a solution to a system of linear equations as the place where the graphs of both equations or lines intersect. In 2D, there are 3 possible outcomes. You can get 1 point. And that's where you have 2 separate lines and looking like this, and they intersect at exactly 1 point. Then the coordinates of that point is your solution. Or you can have no solution. This only occurs if you have parallel lines. That's because if I draw 2 lines with the same slope, they are never going to intersect. You can also have infinitely many solutions. This is when they are the same line. So for example, you could have something that looks like that, and then just right on top of it. Now you might ask, what would that system look like? But for example, it could be y equals 2x plus 1 and negative 4x plus 2y equals 2. This could be your system of equations, and they look like different equations, but they're actually the same equation if you solve them both for y, and they'll lie right on top of each other. In this case, there's infinitely many solutions, but not any number is a solution. For example, if I plug 0, 0 in this particular one, it does not work. So in general, you'll write the equation like x comma 2x plus 1. So it's an infinite number of points in this form, Or you could have also done, what does it come out to be? 1/2 y minus 1/2 comma y. So you could have wrote the solutions either way. Solving systems by substitution. While effective, solving a systems graphically can be tedious and limiting, especially when the solution has fractions or the lines are nearly parallel. Not exactly, but nearly. Instead, we can solve a system of linear equations algebraically using a method called substitution. Example 3. Solve the system of equations negative x plus y equals 3 and 3x plus y equals negative 1 by using substitution. Step 1. Choose an equation and solve for the first variable in terms of the second variable. The first variable can either be x or y, depending on what looks simpler to solve for in the system. In this system, I'm going to choose to solve the first equation for y. That was an arbitrary choice. You could have did any choice you wanted. So then after solving for y, the first equation becomes y equals x plus 3. Step 2. Substitute your solution from step 1 into the other equation. Now that's the important part, because if you just plug it back into itself, you're always going to get infinitely many solutions. This makes a linear equation with only one variable. So solve this equation for the only variable it has. So now I'm going to take this y equals x plus 3 and substitute it into the 3x plus y equals negative 1. So again, the y is equal to x plus 3. So we get 3x plus x plus 3 equals negative 1. Now I'm going to solve this equation. So I'm going to subtract 3 from both sides. Combine like terms, we get 4x equals negative 4. Divide by 4. Divide by 4. We get x equals negative 1. And we can move on to step 3. Now you resubstitute your solution from step 2 into either of the original equations. So that's a key part. You always want to plug it into an original equation. Again, this makes the linear equation with only one variable. So solve this equation for the only variable it has. So I'm going to plug it into the first equation. So we get negative 1 plus y equals 3, which becomes 1 plus y equals 3. Subtract 1 from both sides, and we get y equals 2. Step 4, put the solutions from step 2 and 3 together into an ordered pair. This ordered pair is your solution. If desired, check in both original equations. So our final answer here is negative 1 comma 2. Solving systems by elimination. Another way to solve a system of equations algebraically is through elimination, which uses the following two properties of equations. Addition property of equality. If A equals B and C equals D, then you can add those together to get A plus C equals B plus D. And the multiplication property of equality. If A equals B and K is a constant, then A times K equals B times K. There's a little typo in the notes there. So example 4, solve the system of equations 2x plus y equals 5 and x minus y equals 4 by elimination. Start with both equations in standard form. So ax plus by equals c. Well, this is already in standard form. So we got 2x plus y equals 5 and x minus y equals 4. Then eliminate one variable by using the properties of equality stated above. The eliminated variable can either be x or y, depending on what looks simpler to eliminate. Now for this example, y is simpler to eliminate, but for a teaching choice, I'm actually going to eliminate x. So, since I want to eliminate x, I need these two x values to be opposites of each other. So, well, this is a 2 already. What is the opposite of 2? Negative 2. So I'm going to multiply the second equation by negative 2. Then this system of equations becomes 2x plus y equals 5. Negative 2x plus 2y equals negative 8. Now I'm going to add these two equations together. So 2x plus negative 2x is 0, and that's why we call it elimination, because those eliminate each other. And y plus 2y is 3y. Oh, forgot the negative sign on the 8. And then 5 plus negative 8 is negative 3. Now, in this example, I only multiplied one of the equations by a constant. It is possible you will have to multiply both equations by a constant to get the variables to be opposites of each other. Then step 2, the above elimination step will result in an equation with only one variable, whichever you did not eliminate. Solve this equation for the remaining variable. So we get 3y equals negative 3. Solve for y. We get y equals negative 1. Now step 3 is the same as the previous step 3, where we're just going to plug this back into one of the original equations. I'm going to plug it into the second equation this time. So we get x minus negative 1 equals 4. X plus 1 equals 4 minus 1 minus 1. X equals 3. And then our final answer is 3 comma negative 1. Don't forget, you can plug this back into both original equations to check your work. And that's it for this part of the notes.